All right, welcome to Chapter 7, Section 4, called Indirect Proof. This is for IM II or Integrated Math 2. So a couple of things you'll see on your screen here. You'll see a due date when you first start. You don't see it on my screen for the teacher preview, but you'll see it on your student screen. Number of attempts is always unlimited, and that's true for homework, tests, and quizzes. This particular assignment only has one question on it. Grading policy is always best score, so whichever attempt is the best is the one you keep. And partial credit's enabled. So in this case, you have to answer the one question to get credit for anything, but normally you can get partial credit for answering only one of so many questions. So down here it says, please, once you start your homework, you must finish your homework before you can work on anything else. So that means once I click start here, I have to click the submit assignment button that I see down in the bottom right corner before I move on. Otherwise, Alex is going to freeze out kind of everything else. It's going to lock up all of my other screens, just like that other screen said. I can't work on anything else because it's assuming I want to leave my attempt open. Remember, you have unlimited attempts, so you just always click that submit assignment button so it doesn't do that. Number two, it's going to affect the grade book when I click the submit assignment button because otherwise it's just kind of paused or frozen. My teacher can't see anything. On the side here, we have explanation, example, and message center. So explanation quite literally gives you the answer to the question you're looking at. So it's telling you you're going to lose your question attempt because it's not going to give you the answer and then lets you come type the answer in. Example gives you an example of what it is we're working on for this topic. You can close this and you can open up a new one if you would like. And then the message center, you can message your teacher directly from here. It says it's not enabled because I'm on the teacher preview, but normally it'll open a message that you can send to your teacher with a picture of this attached so that your teacher can see kind of where to come help you. Okay, so let's talk about indirect proofs. So indirect means that it's not direct. So we're going to kind of prove the opposite or the contradiction to make our point here. So we're given, and they're not even showing us a picture here, so I'm actually going to make this a little bigger because we don't have a picture to look at here. We could draw a picture off to the side if we wanted to, but we'll just kind of talk through this one. So we're given the triangle ABC. So we're just given a triangle ABC. And we want to prove that ABC is at most, or has at most one obtuse angle. And this is actually going back to the angle sum theorem. So we're going to kind of use that angle sum theorem to prove this point. And remember, the triangle angle sum theorem says that the angles of a triangle have to add up to 180 degrees. So we're going to use this idea to prove our point. So first, we're going to assume this conclusion is false. That's what a contradiction means. We're just going to prove, okay, well, we're assuming that it's false, that it can have more than one obtuse angle. So we assume the contradictory statement, which is triangle ABC has at least two obtuse angles. So it says at most one. This says at least one, exactly one, no obtuse angles. So I think we're going to prove that it has at least two, I believe. And so we're going to say is true. Has at least one obtuse angle is false, I think, actually, because we're proving that the opposite of this specific statement. So this assumption does not state which angles are obtuse, but without loss of generality, we can assume that angle 1 and angle B are obtuse. That is, that angle A is greater than 90, and angle B is greater than 90. Like this. So let's see. Now, the third angle, angle C, satisfies angle C is greater than 0. Let's see. Using 1 minus 3, or 1 through 3, and addition properties of equality, we conclude that angle A plus angle B plus angle C would have to be greater than 180 degrees. Oop, and I meant greater than. I said greater than, I picked less than. Silly me. So they'd have to be greater than 180 degrees because 90 plus 90 is already 180. And we're saying that they're greater than 90s. So we have more than 180 degrees. We also have to have greater than 0 degrees for it to be a third angle. So we are way over 180 degrees at this point. Or not way over, but we're over. Because they could all be 1 degree over, and this could even be a 1 degree angle. So we could only be a little bit over, but still, we're breaking that rule. So, but this contradicts the triangle angle sum theorem, or property, which states that angle A plus angle B plus angle C have to equal 180. They can't be more than 180. They can't be less than 180. They need to equal 180 degrees. So therefore, the assumption made is true. Sorry, the assumption made is false. We assumed our assumption is false. And ABC has at most one angle is true. So when we're doing an indirect proof, we say whatever it is we're trying to prove, we're going to assume is wrong. And we're going to try to prove that that's wrong. Let's make some statements on why it's wrong. And then go through and decide, okay, does that actually work, it being wrong? Or can we prove that what we just said is in fact not true because we're breaking some other rule? So it's just, indirect proofs are kind of a backwards way of going through proofs. Let's see, the contradiction statement is incorrect. Okay, so let's see. We're going to go with this one. It was the first one that I chose, is true. So let's see if that fixes it real quick. Yay! Okay, so I'd assumed we were trying to go with this one. Exactly, but I chose this one first and then changed my mind. So we're saying that it has at least 2 obtuse angles instead of at most 1. It's just the wording there was a little funny. So this is just the idea of indirect proofs. We only practiced this one time, I think. So I will see you in section 5.